squares end in the same last digit. 1 squared and 9 squared both end in 1. 2 squared and 8 squared both end in 4. 3 squared and 7 squared both end in 9. And 4 squared and 6 squared both end in 6. The square of 0 ends in 0. That's different from all the other squares listed here. And the square of 5 ends in a 5, and that's different from all the other squares listed here. So I will illustrate the method with an example. Let's calculate the square root of 1600. First, look at the last digit of 1600. This is 0. So you now want the square whose last digit ends in 0. There's only one option, which is 0 squared is equal to 0. So we put a 0 over here. Then we cross out the hundreds and units digits. We're left with the number 16. We now want to find the square that's closest to 16 without exceeding 16. In this case, 4 squared is equal to 16 exactly. So we will write the digit 4 here. Thus, the answer is equal to 40. Now, this was a simple example. You probably could have calculated it without this method. But this method will show its value in more difficult examples. So let's go ahead with another example. Let's calculate the square root of 4225. The last digit is 5, and that corresponds to the last digit of 5 squared, which is equal to 25. So we write the digit 5 here. We then cross out the last two digits. We now want the square that's closest to 42 without going over. So that will be 6 squared, which is equal to 36. So we write a 6 over here. Thus, the square root of 4225 is equal to 65. Now, let's go to a little more complicated example. Let's calculate the square root of 841. The last digit is 1, and that could either correspond to 1 squared, which ends in a 1, or it could correspond to 9 squared, which ends in a 1 as well. So we have two options of 1 and 9. We'll sort this out in a little bit. We'll continue by crossing out the last two digits. Now we want the square that's closest to 8 without going over. So this will be 2 squared, which is equal to 4. So we write a 2 here. So now we need to go to two options. We either have 841 is equal to 21 squared or 29 squared. To distinguish between the two, we'll use a genius method. We will calculate the square of 25, which is in between 21 and 29. So there's a trick to calculating the square of a number that ends in 5. You take the part of the number that's not 5, in this case 2, and you multiply it by 1 more than itself. So we take 2 multiplied by 3, which is equal to 6. Then you append a 25. So 25 squared is equal to 625. Notice 625 is smaller than 841. So 25 squared is too little. So it must actually be the case that 841 is equal to 29 squared. Thus, we take the larger option of 9. So the square root of 841 is equal to 29. This may sound a little complicated, but it'll get easier as we work through more examples. Let's now calculate the square root of 3969. We go to the last digit of 9, and we know that it's either 3 or 7. We then cross out the last two digits, and we look for the square that's closest to 39 without going over. This will be 6 squared, which is equal to 36. So we now need to differentiate between 63 and 67. We will calculate the square of 65, which is right in the middle. So we take 6 and multiply it by 1 more than itself to get 42. Now notice, if we have 4225, that'll be larger than 3969. So 65 squared is too large. So it must instead be equal to 63 squared. So thus we know the square root of 3969 is equal to 63. Wow. Let's now calculate the square root of 1156. From the last digit, we know the options are either 4 or 6. We then cross out the last two digits. We look for the square closest to 11 without going over, which will be 3. We now need to differentiate between 34 and 36. So we take 3 multiplied by 1 more than itself, which is 12. Now 12 is larger than 11, so we need to pick the smaller option of 4. Thus, the square root of 1156 is equal to 34. We can adapt this solution to calculate the square root of 11.56. This will be equal to 3.4. Now let's calculate the square root of 16,384. From the last digit, we know the two options are either 2 or 8. Then we cross out the last two digits. We want the square that's closest to 163 without exceeding 163. This will be 12 squared, which is 144. We now take 12 multiplied by 1 more than itself, which is 156. Then we see that 156 is smaller than 163, so we take the larger option of 8. Thus, the square root of 16,384 is equal to 128. Wow. I will mention that you can also adapt this method to calculate the cube root of a number. You of course first have to memorize the cubes of the numbers from 0 to 9. Then the procedure is very similar. In fact, it's even easier because each of the last digits is different. So we look for the cube whose last digit is equal to 4. The only option is 4 cubed, which is equal to 64. So we put down a 4 here. We then cross out the last 3 digits. We look for the cube that's closest to 39 without going over. This will be equal to 3 cubed, which is 27. So we put a 3 here. Thus, the cube root of 39,304 is equal to 34. Amazing! Now, in the present day, we often take arithmetic for granted because we have pocket calculators and powerful computers. But historically, the new calculating methods were revolutionary. Let's go back to the early 1200s in Europe when Roman numerals were the standard practice. Good luck trying to add, multiply, or calculate the square root of Roman numerals in your head. Calculations were instead done on an abacus and translated back and forth to Roman numerals. But with Indian numerals, calculations could be done directly from the numerals. The adoption of the Indian numerals didn't happen right away. There was actually a competition between the two systems, and it took hundreds of years until Indian numerals became the standard. I will close with a quote from the great French mathematician Laplace. "It is India that gave us the ingenious method of expressing all numbers by the means of 10 symbols, each symbol receiving a value of position as well as an absolute value." A profound and important idea, which appears so simple to us now that we ignore its true merit. But its very simplicity, the great ease which it has lent to all computations, puts our arithmetic in the first rank of useful inventions. And we shall appreciate the grandeur of this achievement when we remember that it escaped the genius of Archimedes and Apollonius, two of the greatest minds produced by antiquity. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems one video at a time.